Okay, so we're diving into the tech stack now. This chapter focuses on how we'll build the backend services, right?
Exactly. We'll be looking at languages, frameworks, architecture choices, and libraries like ORMs and for background jobs. It's all about the nuts and bolts of development.
And it sounds like you're prioritizing .NET because of its ease with arrays and asynchronous code. Makes sense, given your experience.
Absolutely. Familiarity is key. .NET offers good tools for APIs, databases, and even distributed messaging systems like Kafka. Plus, the auto-testing capabilities are important.
You mentioned using a command handler approach over a service layer approach. Can you elaborate a bit more on that? What are the benefits you see?
With command handlers, the internal implementation details of a component become less important. You just focus on the command and its handling. This leads to better separation and easier maintenance. Think more modularity.
I see. So, using commands instead of services is more focused on use cases. That would allow us to isolate parts of the system. So, no more spaghetti code?
Exactly. It's about modularity and avoiding those interdependencies. Though it's not a one-size-fits-all solution and the right architecture depends on the project's complexity. The book touches on other approaches like clean architecture. You'll see how each has its pros and cons.
Right, regarding the database. You're choosing Dapper over Entity Framework for performance. Sounds faster.
Precisely. Dapper is a micro-ORM. Its focus is on efficiency. EF is a more feature-rich ORM, but for this project, I believe the gain in speed outweighs the loss of some features in Dapper. We can always adapt as the project grows.
Okay, so the front end wasn't a priority initially. You mentioned focusing on the back end first, correct?
Absolutely. Building the front end later is a valid strategy. It allows you to validate the back-end functionality before significant investment. For a simple application, it's efficient.
And you used React for the front end. Why React, given your familiarity with other options?
React was familiar. Using a pre-built component library saved time on non-critical features. Efficiency was crucial during initial development.
You also mentioned a pragmatic approach to choosing a language and framework. What do you mean by that?
Avoid rushing into learning a new language just for the sake of potential advantages. Stick with what you know well, especially at the beginning. Prioritize building the system over trying to learn something entirely new, as experience with the known technology stack is a time saver.
So, you chose C# for its familiarity, even though other languages like C++ might offer better performance for tasks like trading robots?
Correct. C# provides necessary libraries and tools. If a performance bottleneck arises later, specific sections can be rewritten in a faster language like C++ without compromising the initial launch. The key is building on solid foundations, and C# was seen as the best choice for the first development phase.
So, you're emphasizing comfort and familiarity with the technology stack. That makes sense. How important is the initial choice of language, really?
It's crucial for early development. A familiar language and framework expedite progress. Reliable libraries for API, database, and event streaming platforms are also paramount.
You mentioned .NET and Nest.js as examples of frameworks. What's the difference in your experience with these?
Both .NET and Nest.js are strong choices for building back-end systems. In this project, .NET's ease with arrays and asynchronous code, along with better auto-testing tools, made it the better fit.
You're advocating a pragmatic approach. What does that mean in the context of choosing architecture patterns?
Don't overcomplicate things initially. A clear and simple architectural design is essential. Focus on good structure and a clear division of responsibilities early on. Start with a well-organized approach. More complex patterns like onion architecture can be implemented later if needed.
So, for starting a project, a clean and well-defined initial structure is more important than implementing intricate architecture patterns?
Exactly. The initial structure should facilitate understanding and maintainability. Later, the project can evolve to support more complex patterns if necessary. Begin simple and then scale complexity based on project growth.
So, you're saying spaghetti code, while perhaps initially functional, isn't ideal for larger projects?
Precisely. The lack of structure makes the code difficult to understand and maintain. Changes in one area have a high risk of unforeseen consequences in other parts of the system. New developers face a steep learning curve.
What's the next step up from that in terms of architecture?
A more structured approach emerges. Layers like a UI layer for presentation, a business logic layer for core functions, and a data access layer to manage databases help isolate responsibilities.
But how does that improve things compared to spaghetti code?
Isolation mitigates the risk of widespread errors from changes. Controllers and repositories become logical units, making the code more understandable. While still somewhat interconnected, the code is more organized.
But aren't these layers still connected?
Yes, but that's precisely where more advanced architectures come in. Tight coupling between layers might still pose problems.
So, early applications often relied on spaghetti code. Why was that the case?
The developer community hadn't standardized application structures yet. Modern architectural approaches weren't developed. It was simply what developers could do at the time.
While spaghetti code is useful for quick tasks, it's not ideal long-term. What's the next step up?
Clean architecture introduces layers to organize spaghetti code. A UI layer for presentation, a business logic layer for core functions, and a data access layer manage database interactions. This helps isolate problems.
How does layering solve the issues of spaghetti code?
Layering isolates responsibilities. Changes in one layer don't necessarily affect others. This makes the code more maintainable. Controllers and repositories are better defined units, leading to easier understanding.
So, layering is a step toward more maintainable code, but the layers themselves are still interconnected.
True, but different architectural designs address different levels of connection. A more organized structure is a crucial intermediate step toward robust, maintainable applications.
So, these initial layers, while better than spaghetti code, still have issues.
Correct. Tight coupling between layers can still lead to problems. The business logic layer relying on the data access layer violates solid principles.
What do solid principles offer?
Solid principles address issues with tight coupling. Single responsibility means each part has one job. Open/closed means you can extend without changing core code. Liskov substitution helps with inheritance. Interface segregation splits interfaces for clarity. Dependency inversion decouples high-level modules from low-level ones.
How does that relate to improving the architecture of the code?
By applying solid principles, the business logic becomes independent of the data access layer. This improves flexibility and maintainability. You can change the data access layer without affecting the core functionality.
So, clean architecture is the result of applying solid?
Precisely. Clean architecture separates the domain layer business logic from the implementation details. This improves the overall structure.
What are the advantages of having a completely decoupled business logic layer?
It makes the code much easier to test, and the business rules much easier to modify without affecting the code that interacts with the data. Modifications are isolated and less prone to errors.
Dependency inversion, a solid principle, suggests top-level modules shouldn't rely on lower-level ones. Why is this important?
Creates a more flexible and maintainable structure. Changes at a lower level won't affect higher-level modules. This is crucial for large systems.
But even with clean architecture, complex applications with many services can become tangled. How does the mediator pattern help?
The mediator pattern, using commands and handlers, decouples services. A mediator class acts as an intermediary, receiving and routing commands instead of services directly communicating.
So commands go to a mediator, and the mediator figures out which handler handles the specific command.
Exactly. This reduces tight coupling, making services more independent. The handler itself can work with multiple components or legacy code without the main system needing to know the specifics.
What are the benefits of this approach compared to layered architecture?
The key advantage is decoupling. The inner workings of the handler become irrelevant. This simplifies understanding and makes maintenance simpler, especially in large applications. It's less likely to have problems in one service causing problems elsewhere.
So, The mediator pattern decouples classes by using an intermediary. Commands are sent to this intermediary, not directly to a handler.
Correct. This central intermediary routes commands to the appropriate handler, regardless of its internal structure. This significantly reduces dependencies.
This approach seems promising for larger applications. What other advantages does it offer?
The handler's internal workings, whether using the domain model or legacy code, are hidden from other parts of the system. This makes the application more modular and maintainable. Changes to one part are less likely to affect others.
This modularity is important, especially for legacy code integration. Is there a downside?
There's no universal solution. The best approach often depends on the developer's experience and preference. A service layer might be easier to implement in specific cases.
So the key benefit is reduced coupling? The internal implementations of the handlers don't need to be exposed.
Precisely. The system focuses on the command and its handling without getting bogged down in the complexities of internal structures of the modules.
This allows for greater flexibility?
Definitely. Modifying or replacing parts of the system without disrupting other components becomes easier and safer.
So, DDD advocates for a rich domain model with a lean service layer, right? Classes handling the domain logic are more substantial.
Exactly. Data structure and behavior are tightly coupled within domain model classes. This contrasts with the anemic model.
How does the anemic model differ? Is it less complex then?
The anemic model separates data structure from behavior. Classes like entities and services handle different aspects. It's a more straightforward approach, but some consider it less robust.
Why is DDD sometimes considered expensive? It's about deep domain understanding, right?
Yes. Building a rich domain model requires a thorough understanding of the specific domain, not just the mechanics of the code. The domain itself needs to be well-defined and stable for a rich model to be effectively implemented.
So, anemic models might be simpler to implement initially, but DDD leads to more robust and adaptable systems in the long run?
Potentially. Building a rich domain model takes more time and effort up front, but a well-designed DDD system can be more adaptable to future changes and maintainable in complex projects.
But anemic models are common on GitHub. Is there a reason why this might be?
Anemic models often suffice for simpler projects or cases where the domain is not fully understood at the beginning. It provides a more pragmatic start and is arguably faster to implement, given the initial uncertainties.
So there's a trade-off between initial development speed and potential long-term maintenance when choosing between DDD and the anemic model?
Precisely. Anemic models offer a fast, more straightforward implementation, while DDD, when done properly, can lead to more adaptable and robust solutions. It's important to assess the project's complexity and expected future changes.
So, new applications often lack a fully defined domain. Building a complex domain model from the outset might be premature.
Precisely. Starting with a simpler anemic model allows for faster initial development, making it practical for new projects where the domain's shape isn't immediately clear.
An evolutionary approach, then, might be a good strategy. Gradually refining the model as the system evolves makes sense.
Yes. Building a rich domain model later, after the application is established, is a more realistic approach for a new project. It reduces initial risk.
What about database interaction? Which ORM is preferred?
Dapper is chosen for its speed. While Entity Framework offers more features, Dapper's efficiency is a priority in this case.
The speed gain is a significant benefit. What compromises are involved with using Dapper?
Dapper is a less feature-rich ORM. Certain functionalities will need to be implemented manually, which adds development time.
This trade-off between speed and feature completeness seems necessary. Is there a benefit to this trade-off in terms of maintainability?
Yes, focusing on the essential aspects of data mapping through Dapper might improve the maintainability of simple interactions with the database. Complexity is reduced.
Our goal is speed and efficiency. Why is Dapper a better choice than Entity Framework for this system?
Dapper's performance is superior. It prioritizes direct database interaction, which is crucial for speed-critical applications. Entity Framework adds layers of abstraction which can introduce overhead.
But Entity Framework offers more features. What are the downsides of sacrificing those features with Dapper?
Using Dapper requires manual implementation of some database functionalities. This could increase development time compared to Entity Framework's built-in features. However, the efficiency gain might offset this.
We're focusing on the basic entity structure for exchange order and exchange deal. How does the simplified anemic model for these classes help achieve this speed?
Maintaining a simple structure for exchange order and exchange deal without unnecessary complexity allows for faster data mapping to the database. The anemic model prioritizes direct mapping, which contributes to speed.
You mentioned the trade-off between speed and features. How does this manifest in practical terms in creating our entity classes?
Creating the exchange order and exchange deal classes directly for database mapping is a simpler approach than creating intermediary classes. It reduces abstraction layers, which contributes to faster execution.
So, the focus on direct database interaction and a lean model contributes directly to speed in this context. Is this trade-off sustainable for more complex scenarios?
It depends on the system's evolving complexity. This simplified approach might suffice for the initial phase, and we can refactor as needed later. The initial speed gain is a priority here.
These entity classes seem straightforward. How does the direct mapping to PostgreSQL tables affect performance?
Direct mapping minimizes abstraction layers. This reduces overhead in database interaction, which directly impacts the speed of data retrieval and storage.
The use of double quotes around table and column names in the PostgreSQL queries is crucial. What's the reason behind this specific choice in a .NET environment?
PostgreSQL, unlike some other databases, doesn't enforce snake_case for identifiers. Using double quotes ensures compatibility with PostgreSQL's naming conventions, avoiding potential query errors.
The exchange deal class doesn't have its own ID. Why is this design choice appropriate in the context of exchange order?
Deals are inherently linked to orders. The exchange order ID field in exchange deal establishes this relationship. This eliminates redundant data, improving efficiency.
This design choice avoids redundancy, but could it affect querying or complex operations down the line?
Potentially, but in the initial phase of the project, avoiding a complex model is more beneficial. We can adjust this design as the system grows more complex.
The focus on speed seems to be the paramount factor, but could this design choice compromise flexibility in the long term?
Perhaps, but this simplification is a necessary trade-off for the immediate goals of speed and simplicity. Flexibility can be added later as requirements change.
The choice to use Pascal case for our classes and tables, even with PostgreSQL's snake_case preference, seems a bit unusual. Why this deviation from convention?
Maintaining consistency with C# naming conventions is important. It's easier for developers familiar with C# to work with Pascal case naming.
The exchange deal class lacking an ID seems like a critical design decision. How does this affect the potential for future modifications or queries if the deal has to be retrieved independently?
While independent retrieval might be needed later, initially, the direct link to the exchange order via exchange order ID is simpler and more efficient.
Implementing a DB connector class for database connections seems a step back. Wouldn't a higher-level ORM handle this automatically?
A higher-level ORM like Entity Framework abstracts away database connections, but Dapper provides more control, allowing for fine-tuning of performance, especially in a performance-critical system.
This DB connector class is rudimentary. How does it handle potential database errors, like connection timeouts?
The example shows basic error handling using transactions. More robust implementations would add checks and retries for failed connections.
This code snippet shows a transaction. What are the potential pitfalls of using a single connection per operation?
Using a new connection per operation might lead to connection exhaustion if many requests are handled concurrently. However, in the current context, this approach appears sufficient for the present load.
The try-catch block handles exceptions, but doesn't specify how connection errors, like timeouts, are managed. How can we enhance this error handling?
Adding retry mechanisms for connection failures or logging detailed error information would enhance the robustness. A configurable retry strategy could be added for specific types of errors.
The code commits or rolls back a transaction. How does this affect concurrent access to the database, especially with multiple clients accessing the database at the same time?
The transaction ensures atomicity, preventing data inconsistencies during concurrent operations. However, the number of concurrent clients needs consideration. The system needs to be monitored for potential bottlenecks.
Is there a way to improve the connection pooling mechanism to prevent connection exhaustion issues?
The code doesn't include a connection pool. Using a connection pool is a standard practice for improved performance and resource management in concurrent environments. This could involve using a library like npgsql connection directly.
The repository interface defines methods for insert order async and insert exchange deal async separately. Why is this separation necessary, given exchange deal S dependency on exchange order?
This separation reflects the asynchronous nature of data arrival. Deals might be processed separately and in a different order than the associated order. The code needs to handle this decoupling correctly.
The separate insert order async and insert exchange deal async methods seem a bit unusual. Why not handle exchange deal insertion within insert order async?
Data might arrive out of order. Handling them separately allows for flexibility in dealing with the asynchronous nature of order and deal processing.
The insert order async method uses Dapper contribution. How does that simplify the process compared to manual SQL queries?
Dapper contribution handles the mapping to SQL automatically, saving the developer time. Without it, we'd need explicit SQL insert statements.
The retrieval of exchange order and exchange deal in get order async uses separate queries. Does this potentially lead to inconsistencies if either query fails?
Yes, there's a risk of inconsistencies. A transaction around both queries is crucial to ensure data integrity. The code needs this transaction handling.
The example shows a semicolon separating the SQL queries. How is this approach efficient in handling the potential of large datasets?
Using semicolons for multiple queries is straightforward for small datasets. For large volumes, more sophisticated approaches might be needed to batch the queries or employ more efficient database methods.
Handling asynchronous data arrival in the repository is a good design choice, but requires robust error handling. What steps can we implement to manage potential failures in saving deals or orders?
Including comprehensive error handling and logging is essential. Checking for null results, logging specific errors, and potentially implementing retry mechanisms for failures would improve resilience.
The getOrderAsync function retrieves orders and deals separately. This approach might lead to inconsistencies if the second query fails after the first one. How can we ensure data integrity?
A crucial step is to wrap both queries within a single transaction. This guarantees that either both queries succeed or neither does, preventing inconsistencies.
The code uses query multiple async. How does this affect the overall performance compared to running separate queries?
Query multiple async is potentially more efficient for retrieving multiple related results from the database. It reduces the number of round trips to the database.
The getOrderAsync function concatenates SQL queries with semicolons. Is this a good approach for complex queries or large datasets?
Using semicolons is fine for simple cases, but for large datasets or intricate queries, a more structured approach might be better. Consider using stored procedures or batching.
The function returns null if the order isn't found. What if the deal query fails for a valid order? What is the handling for that?
The current code doesn't handle the case where deals might be empty or null, potentially resulting in an exception later. The code needs to explicitly handle this potential null value. Add a check and appropriate handling.
How can we improve logging to aid in debugging and performance analysis when dealing with database interactions in getOrderAsync?
Adding detailed logging statements, especially when exceptions occur, will help diagnose problems and analyze performance bottlenecks. This could include logging query execution times and potential issues during data retrieval.
The semicolon approach might be less maintainable for complex queries. Are there any alternatives that provide better structure and readability?
Using stored procedures can improve code structure and maintainability for complex queries. They encapsulate the queries and reduce the need for concatenating multiple queries.
The example uses Fluent Migrator for migrations. What are the advantages of using a migration tool compared to manual SQL scripting?
Migration tools like Fluent Migrator automate the process of creating and managing database schema changes. This reduces the risk of errors and improves consistency in the database structure.
The migration code creates exchange orders and exchange deals tables. What data types are used for amount and price?
Amount and price are decimal types with 20 digits for the integer part and 10 for the fractional part. This precision is suitable for financial data.
The up method creates the tables. What happens in the down method?
The down method drops both exchange orders and exchange deals tables, effectively reversing the up method's actions. This is crucial for managing database schema changes.
This migration code is quite straightforward. Are there any considerations for potential data loss during schema changes?
Yes, if the application is live and data exists in the tables, there's always a risk of data loss if the migration isn't carefully planned. A rollback plan and thorough testing are essential for migrations.
The use of double quotes around table and column names in the PostgreSQL queries seems peculiar. Why are those necessary?
PostgreSQL requires double quotes for identifiers, column and table names that don't follow the snake_case convention. This is a PostgreSQL-specific requirement.
Is there a reason for using a specific naming convention for the columns in C# and not for PostgreSQL tables?
While snake_case is common in database schemas, it's generally recommended to use Pascal case for C# classes, properties, and fields. Using matching conventions within different contexts can aid maintainability.
Finite state machines are mentioned. How would they be implemented in a real-world scenario?
Finite state machines represent processes with discrete states and transitions. In real-world code, libraries or custom classes are often used to represent and manage these states, transitions, and associated actions.
So, a process map manages transitions between nodes. How is this implemented concretely? Do we build a lookup table?
A process map likely uses a data structure like a directed graph or a map. Nodes are defined with their actions, types, and connections to other nodes.
How do events trigger transitions to different nodes? Is it a separate event listener system?
Yes, a dedicated system listens for events. When an event occurs, it checks the process map for the matching trigger node and updates the entity's current node accordingly.
What about handling waiting nodes? How do we enforce timeouts?
Waiting nodes have a timeout. A timer or scheduler would handle these, triggering the transition to the next node if no event occurs within the timeout.
5 node types are mentioned. Can you elaborate on how a complex process flow might be structured using these?
A complex flow chains together act, waiting, and trigger nodes. Terminal nodes mark the end of the process. The branching can involve multiple trigger nodes based on different events.
How do we handle errors or exceptions within the various node types?
Error handling needs to be built into each node type's actions. For example, if an act node fails, it could log the error and potentially transition to a dedicated error handling node.
So a terminal node signifies the end of a process. How are entities removed from the process queue at a terminal node?
Entities are removed from the queue and processing stops when reaching a terminal node. This is typically handled by a removal process triggered by the node itself.
The example shows a stop and report node. Is that a terminal node or an act node?
It's an act node. It performs an action, like logging a stop message, but doesn't mark the complete end of the process itself.
The subtheory completed event triggers a transition. How does this triggering actually work in code?
Code would check for the event and, if matched, update the entity's state to the appropriate next node.
Why are description nodes included? They don't seem to have actions.
Description nodes act as placeholders. They're part of the process flow, but don't involve any specific actions. They help clarify the process map structure.
The example shows a check exit condition action. How might a failing condition affect the flow?
If the exit condition fails, the entity returns to a previous node in the flow. This is determined by the check exit condition actions parameters.
Table 5. 1 shows nodes with parameters. How are these parameters used to control the process?
Parameters provide values like IDs or times. They're used to guide actions at each node, such as setting status values, triggering events, or setting timeouts.
Okay, so the parameters in Table 5.1 are crucial for controlling the process. How does the set status second step node use its parameter, the status ID?
The status ID is used as a direct input to the action. This allows you to set statuses for various entities in one place, avoiding code duplication.
The create subtheory node seems straightforward. Are there any specific considerations for its implementation?
Yes, ensure proper isolation. Ensure the subtheory is launched and managed independently of the main process. This might involve background tasks.
The wait node has a one-day timeout. How is this timeout enforced in practice?
A timer or scheduler is likely used. If the subtheory completed event doesn't arrive within a day, the system automatically advances the entity to the next node.
The stop and report node seems important for error handling. Why is it placed in the process flow?
It handles potential subtheory timeouts. The node logs a failure. The process moves to the next step or a dedicated error handling process.
Node 5 subtheory completed event is a trigger. What happens if the event never arrives within the wait node timeout?
If the event never arrives, the timeout on the wait node takes over and triggers a move to node 4.
The check exit condition node seems flexible. Could you provide an example of a condition that might cause it to move to node 2?
A failing quality check condition, for example. The result of the check is used to determine the next node.
This check exit condition node sounds complex. How is the condition failure handled?
The node stores the ID of the node to return to if the condition fails. This creates a loop, allowing for conditional reiterations within the process flow.
Implementing this kind of conditional loop within a finite state machine requires careful design. What are the potential benefits of this approach?
Flexibility is a key benefit. It allows for complex decision-making within the process flow, making the state machine more adaptive to different scenarios.
The discussion mentions a hosted service in .NET. How does this relate to the finite state machine implementation?
Hosted services provide the background process for the finite state machine. The finite state machine runs within a .NET application, handling the entity transitions.
Should the process bot handling entity transitions be tightly coupled to a specific application?
No, ideally it should be a reusable library, decoupled from any specific application. This makes it easily adaptable to multiple applications.
The discussion mentions a liveness probe. Why is this important in a microservice context?
Kubernetes uses liveness probes to ensure the microservice is functioning. This is crucial for maintaining system reliability.
You mentioned the process bot as a reusable library. How might this be structured to facilitate reusability?
Interfaces for actions like iProcessAct should be defined. Implementations of these interfaces within specific applications would be easily plugged in.
How do parameters passed to the hosted service affect the behavior of the finite state machine?
Parameters control the initialization and configuration of the finite state machine within the hosted service.
The process bot library using interfaces for actions like iProcessingAct seems crucial for reusability. How does this decoupling work in practice?
The application provides concrete implementations of iProcessingAct for specific actions. The process bot doesn't depend on the application's specific logic. It only needs the interface.
Listing 5 to 7 shows an extension method for iService collection. Why is this approach preferred for registering the process bot?
Extensions allow clean integration into existing application frameworks, like .NET. It avoids directly modifying the application's core.
The code mentions an act factory type. What role does this type play in the process?
This type is the implementation of iProcessAct factory. It's used to create the necessary iProcessingAct objects for each action.
How are the act assemblies, used in the registration process?
They contain the implementations of iProcessingAct, allowing the process bot to find and instantiate them.
The discussion highlights .NET's extensibility features. What benefits does this bring to application development?
Flexibility and maintainability are key. You can easily add new functionality without changing the core system.
This approach seems like it would create more maintainable code. How about the complexity of the code?
The increased structure might introduce some initial complexity. However, It greatly simplifies long-term maintenance and reduces dependencies, making future development easier.
The extension method for iService collection seems elegant. Why is directly modifying iService collection avoided?
Direct modification can lead to tight coupling. Extensions allow for modularity and maintainability.
Passing a procedure to create process bot options is interesting. How does this enable flexibility?
The user can tailor the options, like database connections, to their application's specific needs. This is adaptable without changing the library itself.
The ActFactory type parameter is crucial. How does relying on an interface instead of concrete types affect the process bot's design?
Decoupling is achieved. The process bot doesn't need to know which specific actions are implemented. It only needs to know the interface.
Assemblies containing iProcessing Act implementations are also part of the registration. How does this ensure all necessary actions are available?
The assemblies provide the concrete classes for the defined actions. This way, the process bot can access the diverse set of functionalities needed.
This layered approach seems well-structured. What potential disadvantages might arise from this complexity?
Initial implementation might be more complex. However, the long-term benefits of maintainability, reusability, and flexibility often outweigh this initial investment.
Adding implementations to the service collection simplifies access. But is there a potential downside to this approach?
Potentially, a large number of implementations could make the collection unwieldy, needing careful management. However, the benefit of reusability outweighs the management.
Services.add hosted service, process bot hosted service, launches the process bot. What's the significance of iHosted service?
iHosted service defines the contract for a hosted service, like the process bot. Start async and stop async methods let the system manage its lifecycle.
The start async function uses an infinite loop. What's the purpose of _stop and cancellation token?
They provide ways to stop the loop. _stop is an internal flag, while cancellation token allows the system to gracefully shut down the process.
The code includes stopwatch. Why is timing important in this context?
Limiting the bot's execution frequency ensures it doesn't overwhelm the system. The stopwatch measures execution time, allowing appropriate delays.
The delay calculation, sleep time, is interesting. How does it prevent overprocessing?
Ensuring the bot's execution time doesn't exceed a predefined limit prevents overwhelming the system. The delay adjusts based on execution time.
Error handling in the try. Catch block is important. Why is a delay included in the catch block?
The delay in the catch block lets the bot recover from exceptions without immediately retrying, preventing further issues.
Overall, this infinite loop approach seems manageable. Are there other alternatives for handling background tasks?
Yes, there are other approaches like using background worker threads or queuing systems. The infinite loop works well for this particular scenario.
The start async function uses a while loop. Why not a for loop in this case?
A while loop is better because the bot continues running until explicitly stopped. A for loop would require a predefined iteration count, which isn't the case here.
The code sets a delay after each iteration. What's the significance of this delay?
The delay prevents the bot from rapidly consuming resources. Without a delay, the bot might attempt processing too many items too quickly, which could overload the system.
The stopwatch measures execution time. Why is this important in managing the delay?
Knowing how long each iteration takes allows the bot to adjust the delay dynamically. This is crucial for handling varying processing times.
The delay is calculated based on the execution time. How does this ensure the bot doesn't get stuck in an infinite loop?
If an iteration takes a long time, the delay will increase to ensure the bot doesn't repeatedly run within a short time frame, thus preventing resource exhaustion.
The catch block includes a delay. Why isn't the bot restarted immediately after an exception?
Restating immediately could lead to a cascading series of exceptions and further issues. The delay allows the system to recover and prevents potential chain reactions of errors.
Are there any potential drawbacks to this specific delay approach?
The fixed delay might not always be optimal for every situation. A more sophisticated approach might involve adjusting the delay based on error frequency or other factors.
The magic numbers for delays are hard-coded. Is there a way to make them configurable?
Yes, making these values configurable is better practice. It allows for flexibility in adjusting the system's behavior without requiring code changes.
While the infinite loop approach is simple, are there more sophisticated alternatives for background tasks in .NET?
Yes, using task queues or background worker threads could offer more robust and scalable solutions for handling background tasks. However, this simple loop approach might suffice for lighter loads.
So, the bot runs periodically. How does it interact with the processing queue?
It retrieves entities from the processing queue and active queue tables. Batch processing multiple entities at once improves efficiency by minimizing the overhead of retrieving and locking individual entities.
The code mentions get and lock entities async. Why is locking needed?
Locking prevents other instances of the bot from working on the same entities. This ensures data integrity and avoids concurrent modifications.
The code mentions that batch processing multiple entities improves efficiency. Why does retrieving and locking entities take significant overhead?
Retrieving and locking each entity individually involves database interactions. Batching reduces these interactions, resulting in faster processing.
Get and lock entities async is in the repository layer, though. Isn't that a violation of the solid principle?
Yes, it potentially moves business logic to the repository. However, for simple processes, this approach can lead to cleaner, more performant code, potentially outweighing the principal violation.
What if the entity isn't ready to be processed yet?
If the entity isn't ready, the bot won't process it. The processing queue and active queue tables can manage the state of readiness to prevent premature processing.
How is the batch size determined?
The batch size is implicit in the way entities are retrieved from the queue. A larger batch size could potentially increase performance if the overhead of fetching data outweighs the cost of processing more entities per iteration.
Is there a concern about the size of the batch and system performance?
A very large batch size might introduce delays due to the need for more processing. A very small batch might potentially degrade performance due to extra calls. A balance is needed.
How does the code handle the processing of entities in the queue?
It fetches entities, locks them, and then processes them in a sequence defined by the process map. This order is crucial for proper state transitions.
The code suggests a potential violation of solid principles with get and lock entities async. Why not handle locking within a transaction?
Separating locking into a transaction would require more complex code, potentially adding overhead. This simpler approach might be acceptable for a system with moderate load. The trade-off is clear: a cleaner, more structured approach against performance.
The concern is that this might not scale well. Could the current approach introduce bottlenecks?
Yes, if the processing queue grows very large, the bottleneck might occur at the locking and fetching of entities. We might see performance degradation.
So, a more structured approach with transactions might improve maintainability and scalability in the long run, despite the added complexity. Are there ways to potentially mitigate the bottleneck now?
Potentially, batching and adjusting the batch size based on performance monitoring can be incorporated now. It provides a way to test the scalability of this section.
How does the size of the batch impact the decision? Could it introduce more latency to the application?
A large batch size might delay the immediate unlocking of entities, potentially increasing latency. A smaller batch would require more iterations, potentially affecting the overall system performance.
The process map class is introduced. Why not define it as an entity if applicable to the architecture?
This decision aligns with the anemic model approach. Process map in this context is more akin to a service-like class, handling the logic of process map navigation. A rich model might not be as practical for the current system's design.
How does the process map class interact with the entity queue?
It is not directly involved with the entity queue. It calculates whether the entity should advance along the process map. This separation is in line with the layered approach in the architecture.
So, the code processes multiple entities at once. How does it ensure only ready entities are processed?
The processing queue and active queue tables manage entity readiness. The bot only retrieves entities marked as ready for processing.
The text mentions a potential solid principle violation with getAndLockEntities async. Why is this function necessary?
GetAndLockEntities async efficiently retrieves and locks multiple entities for processing, maximizing database interactions. It's a balance between maintainability and speed.
What happens if a batch of entities isn't processed immediately?
Unprocessed entities remain in the processing queue. The bot continues processing entities on the next iteration until it is empty.
How does the code handle concurrency issues related to multiple entities potentially being processed simultaneously?
Locking mechanisms ensure only one bot instance processes each entity at a time.
What are the potential drawbacks of the batch processing strategy?
A large batch size can delay immediate unlocking of entities and introduce latency. Too many iterations could affect the bot's responsiveness in the processing queue.
How does the batch size influence performance?
Finding a balance is crucial. Too large and you have latency. Too small and you lose efficiency. Performance tuning and monitoring is essential.
How does the processMap class fit into this batch processing logic?
ProcessMap determines the next steps for each entity, but doesn't directly manage the entity queue itself. It focuses on the processing flow rather than the retrieval mechanism.
The text suggests a potential trade-off between adhering to solid principles and code clarity. Is there a way to address the potential iProcessing queue repository split without sacrificing readability?
You're right. Simplification is key. The separation might be worthwhile if it introduces major maintainability improvements. We could consider a more abstract iEntity processor interface and then pass different implementations to the handleEntities async function, without the need to make iProcessing queue repository more complex.
How does that impact the handleEntities async function's responsibility? Doesn't it become more involved in managing the entity flow?
Yes, handleEntities async becomes more involved in managing the entity flow. It takes on the responsibility of handling the entity processing queue logic, along with the event processing and the process map. However, this approach gives more control and modularity, which can be a positive trade-off.
If we do the split, how does the processMap class integrate with the new iEntity processor?
The processMap class would likely interact with iEntity processor to define the next step based on current entity state and events. The iEntity processor would handle the low-level database interactions. This separation reduces dependency between processMap and the database layer.
How does this impact the complexity of the moveAsync function? Does it become simpler by offloading the fetching and locking?
The moveAsync function potentially becomes simpler. It receives data through iEntity processor and handles internal processing steps based on processMap instructions. The locking and fetching are handled separately by the repository and processor.
Could this approach lead to performance issues due to multiple interface calls?
Potentially, but the use of interfaces should lead to better code structure and maintainability, which could offset any slight performance impact. Careful implementation of the interfaces and appropriate batching would help mitigate this.
The text discusses using the processMap class instead of an entity. Are there cases where it might still be better to treat it as an entity?
In a more complex system with advanced relationships between process maps, the processMap class might be a suitable entity. However, for this current design, it's better defined as a service-style class to simplify the architecture.
So, handleEntities async first handles events, then processes the queue. Why this order?
Processing events first allows the bot to react to external triggers before continuing the queue-based processing. This ensures the bot responds to events in a timely manner.
What's the purpose of handleEvents async?
It retrieves and processes events related to the entities in the queue. It determines the next node based on event types and updates the entity's position in the queue.
The code filters events by entity ID. What if an event isn't related to any entity in the queue?
The if next node ID has value check handles cases where there's no corresponding event for an entity. In these scenarios, the bot skips that entity and continues to the next one.
The code orders events by creation time. Why is this significant?
Event order matters. The bot processes events chronologically to maintain the proper execution sequence in the process map, preventing issues with events arriving out of order.
The function uses _event repository.getUnprocessed async. How does this function work in relation to the queue?
It fetches unprocessed events related to the entities in the queue, allowing the system to know what events need to be processed before moving to the next node in the process map.
The code updates the queue position after processing an event. How does this affect subsequent processing?
Updating the queue positions ensures that the bot knows the current status of each entity and only processes the next node in the correct state.
If the getNextNodeID function returns null, what does this indicate? And what's the code's response?
A null return from getNextNodeID indicates no matching next node for the event type. The code skips to the next entity in the queue in this situation.
What are the potential risks of not ordering events by creation time?
Processing events out of order could lead to inconsistencies in the state machine, potentially causing incorrect actions to be performed or states to be missed.
The text explains using UUIDs instead of longs for entity IDs. Why is this a better choice for multiple entity types?
Using UUIDs ensures unambiguous identification across different entity types. A long ID could potentially collide for different entity types, making it impossible to reliably determine the entity's type.
How does the system handle multiple events for a single entity?
The system processes events in the order they arrive. This maintains the correct sequence of actions within the process map.
The text emphasizes processing only relevant events. How does the system determine if an event is relevant to the current state?
The system checks if the event trigger is at a lower level than the entity's current position in the process map. This ensures the system doesn't try to apply events that are no longer relevant.
What are the potential benefits of this approach for event handling?
It prevents outdated or inappropriate event processing and maintains the consistency of the process map flow.
Are there any potential drawbacks to this approach?
The system may need to filter events that are not relevant to the current entity state. This could potentially add some complexity to the event retrieval and processing mechanism.
Could there be performance implications from event filtering?
Filtering may introduce a slight performance overhead if not implemented efficiently. Proper indexing and data structures can significantly reduce this overhead.
What are some approaches to optimizing the event filtering process?
Using efficient database queries and indexes would help. For example, including a timestamp or state field with the event to query upon. A good caching strategy might also help.
This function retrieves entity data. Why fetch it now instead of when needed in move async?
Fetching all data upfront reduces database calls during each step of move async. This optimizes performance, especially for many steps.
Underscore process entity data queries dot get data async returns IEnumerable process entity data. Why not just list process entity data?
IEnumerable allows for lazy loading. If only a subset of data is needed, it's more efficient than loading the entire list.
The code uses entities data list. First, d equals d, .id equals q element, .entity ID. What happens if the entity data isn't found?
The first method will throw an exception if the entity data is not present. Robust error handling is crucial here.
This function handles potential exceptions. What's the risk if the exception isn't handled properly?
Unhandled exceptions in this function could halt the processing of the entire queue, impacting overall system stability.
The code uses a try-catch block. How does the catch block improve robustness?
The catch block allows the program to continue processing other entities even if one fails. This prevents a failure in one entity from halting the entire operation.
The function calls move async. How does this affect subsequent processing of the same entity?
Move async is recursive. Subsequent calls will move the entity through the process map, potentially triggering further steps based on the node type.
What are some potential problems with fetching all data at once?
If the entity data is very large, fetching all data at once could put a significant strain on memory and potentially impact performance.
How can you avoid a full dataset load if it's too large?
If data is too large, using lazy loading techniques within getDataAsync or loading only necessary data would solve that issue. An approach that loads data on demand in MoveAsync would also work.
The text mentions the potential for multiple entities. How does this affect the loop structure?
The for each loop iterates over each queue element. This ensures each entity in the queue is processed sequentially.
What's the purpose of storing the entities data list?
Storing the entity's data list allows efficient reuse of the fetch data for the current pass of the processing queue. This is more performant than making repetitive queries to the database.
So, process entity data holds immutable entity data. Why is this beneficial?
It avoids redundant database queries for unchanging data at each processing step. This improves efficiency.
The node class has many fields. What's the purpose of the code field?
The code field orders the nodes in the process map. It dictates the sequence of processing steps.
How do isParent and parent ID relate to entity processing?
These fields allow grouping entities in the process map. Parent node might affect multiple child nodes.
What does the params field contain?
Params holds parameters for executing actions at each node. These values tailor node behavior.
What is the significance of waiting seconds?
Waiting seconds specifies the delay for waiting nodes. Entities pause processing for the defined time.
How do Act ID and Event Type ID affect node processing?
Act ID identifies the action to perform. Event Type ID triggers actions based on received events.
The deleted field seems important. Why mark nodes as deleted?
The deleted field enables a soft delete feature for nodes. Deleted nodes are excluded from the process map.
Considering the many fields in the node class, how do you avoid code complexity?
Using a clear structure and well-defined roles for each field helps maintain code readability and manageability.
So, isParent and parent ID are for grouping nodes. How does this help with different entity types having their own process maps?
Each entity type can have its own parent node. This isolates the process flow for each type, preventing conflicts between different entity types.
The type field in the node class, what does it mean exactly?
The type field specifies the kind of operation a node represents. This allows the system to execute the correct actions based on the node's function.
The fast field, what does it achieve?
The fast field optimizes processing. It allows the system to execute several steps in a single pass, reducing the number of database interactions for quick operations.
The params field, what data type is this field, and what is its purpose?
The params field is a string containing parameters for executing actions in nodes. The string holds specific data for each action.
Waiting seconds, is this a standard practice?
Yes, waiting seconds is a standard way to implement delays in processing flows. It's important for controlling the sequence of operations.
What about Act ID and its purpose in relation to iProcess Act Factory?
Act ID identifies specific actions defined in iProcess Act Factory. This allows for selecting the correct implementation based on Act ID.
What is the function of Event Type ID?
Event Type ID identifies the type of event triggering a transition to another node. This enables the state machine to respond appropriately to specific events.
What is the practical use of the deleted field?
The deleted field allows for soft deletion of nodes from a process map. This way, nodes can be removed logically without physically deleting them from the database.
Okay, Event Type ID identifies event types. Why is this important for the bot?
It lets the bot know which trigger node to activate for a specific event. This ensures correct transitions.
The deleted field is for soft deletion. How does this improve the process map?
Soft deletion avoids physically deleting nodes. It keeps the process map structure clear for maintenance and future use.
The moveAsync function is recursive. Why use recursion here?
Recursion allows the bot to navigate potentially complex process maps. It's not always clear how many steps are required.
Within moveAsync, the node type switch handles different node types. Why use a switch statement?
A switch statement makes the code more organized and readable, handling different node types appropriately.
Make Act Async, make waiting, make terminal async. What do these functions do?
These functions handle actions associated with specific node types. They perform actions related to act, wait, or terminal node types.
Make next step function, what does it decide?
Make next step determines the next node for a node that isn't act, wait, or terminal.
Why is the moveAsync function useful in this process?
It effectively drives the entity through the process map, executing nodes in the defined sequence.
The moveAsync function switch statement has cases for trigger, description, and null. when node.its parent. Why these specific cases?
These cases handle nodes that don't require specific actions. They simply move to the next node in the sequence. Null when node.its parent handles cases where a node might be a parent node in a hierarchy.
The move variable in move async seems crucial. What exactly controls it?
The move variable tracks whether to continue recursively calling move async. It's set to false for nodes like stop and report to prevent further processing after that node.
Why is recursion employed in move async and not a loop?
Recursion allows handling complex process map structures where the number of steps isn't known in advance. Using a loop wouldn't adapt as easily to dynamic sequences.
What role does the next node ID variable play, and why is it sometimes null?
Next node ID stores the ID of the next node in the process. It's null when a node's sequence ends or a transition condition isn't met.
The code mentions make act async, make waiting, and make terminal async. How do these functions differ from make next step?
These functions handle nodes of specific types like act, wait, or terminal, and handle logic unique to each node type. Make next step handles nodes that aren't those special types.
In the make act async function, the iProcessAct interface is used. How does this relate to the purpose of the function?
It allows different actions to be performed within an act node, enabling flexibility and customization for these actions.
In make act async, iProcessAct, act equals underscore process act factory dot get act, node.act ID. What does this line do?
This retrieves an implementation of the iProcessAct interface based on node.act ID. This allows the bot to perform actions specific to the act node.
Why is return false, null, in make act async?
It indicates that after an action, the entity does not automatically move to the next node. The move flag is false to prevent automatic advancement, and next node ID is null because the next step depends on the specific action's logic.
What's the purpose of make terminal async returning? False, null?
Make terminal async signifies the end of the entity's processing. Returning false, null, stops the recursive calls.
Make next step gets next node ID directly. Why not use a switch like make act async?
Make next step handles nodes that are not act, wait, or terminal. A simple calculation of the next node is sufficient.
In make act async, the function underscore processing key repository dot upsert async, entity data.id, node.id processing time. What does this function update?
This updates the processing queue, indicating that the entity has completed an act node, updating its position and the time of the action.
Why is the next node sometimes determined by conditions within the act node?
This allows conditional branching in the process map. An action might trigger a transition to a different part of the process.
Given the next node ID can be null, how does move async handle these cases?
If next node ID is null, the recursive call to move async stops, preventing further traversal.
How does make act async function in the case of a branching action, where the next node isn't the one immediately after?
The action logic itself determines the next node ID, thus allowing the entity to transition to different parts of the map, not necessarily sequentially.
Make terminal async and make next step are straightforward. Why the different structures for those functions compared to make act async and make waiting?
Make terminal async and make next step handle nodes without specific actions. They simply determine the next node. Make act async and make waiting need more detailed logic based on the node type.
Get next node ID is crucial for navigation. What happens if get next node ID returns null?
If get next node ID returns null, it means there's no defined next node, typically indicating the end of the process for that entity.
The get next node ID method has two versions. What's the difference?
The first version of get next node ID takes an event type. It selects the next trigger node based on the event, useful for events triggering different actions. The second version is a general next node lookup, ignoring events.
Why is get next node ID using minby, n equals n.code?
Minby, n equals n.code, ensures the next node is chosen based on its code, likely for ordering in the process map, selecting the next one in the sequence.
What does the code field of the node class represent?
The code field likely orders nodes in the process map, determining the sequence of processing steps.
The deleted field in the node class. What is its function?
The deleted field enables soft deletion of nodes, keeping the process map structure but excluding nodes from processing.
How does the parent ID field in node contribute to the process map structure?
The parent ID field allows for hierarchical organization of nodes in the process map. Nodes with the same parent belong to the same branch.
In the getNextNodeID method, why is n.deleted equals false checked?
Is a crucial part for handling soft deleted nodes. This ensures that nodes marked for deletion are not included in the next node selection.
What does currentNode.parentID accomplish in this query?
CurrentNode.parentID defines the branch of the process map. Nodes with the same parent are part of the same branch.
The query filters by n.code equals currentNode code. How does this affect the selection of the next node?
This ensures the next node is the closest node with a smaller or equal code value to the current node. It essentially selects the next node in the sorted order.
If multiple triggers exist for an event, how does minby n equals n.code ensure the selection of the closest trigger?
By sorting nodes with matching parent and event type by code, minby picks the node with the smallest code value. This node is logically the closest to the current node's position.
How is the concept of a process map different from other architectural patterns like layers or use cases?
The process map focuses on the precise sequence of steps an entity, like a financial transaction, takes through the system. Other patterns like layers or use cases are broader views focusing on different aspects of the system.
The text mentions backworker for background tasks. What specific role does a backworker fulfill?
A backworker handles tasks on a schedule or triggered by specific events. It manages operations not directly related to incoming requests. Examples include checking and updating trading strategies or receiving data from exchanges.
Given a backworker's scheduled nature, how does it interact with the process map functionality?
The backworker might execute tasks on the entities being processed by the process map, and it interacts with data structures for process scheduling or handling data updates. They don't work in direct response to each other, but they share data and tasks.
The backworker uses an infinite loop. How does this relate to the scheduled nature of its tasks?
The loop runs periodically. The loop checks if a task is ready to run based on the last start date, last stop date, and other criteria.
The database schema includes task ID, timestamp, last start date, last stop date. What's the purpose of each field?
Task ID uniquely identifies the task. Timestamp records the current time. Last start date and last stop date track the last execution start and stop times for scheduling.
How does the backworker ensure only one pod handles a task at a time?
The backworker uses a table to track active tasks. It gets a task, locks it, and only then runs it. Locking prevents other pods from taking the same task.
The text says the backworker interacts with a database table to store active tasks. What specific table is being referenced?
The table is called active tasks. It has fields that prevent race conditions when different pods might need to take a task.
What are the benefits of using a database table to track active tasks, rather than just a memory-based lock?
A database-based lock provides persistence. If a pod fails, a database lock is still in place to prevent other pods from immediately starting the same task.
The backworker interacts with a backworker task repository. What is the responsibility of this repository?
The backworker task repository is responsible for interacting with the active tasks database table, enabling the backworker to get and release tasks based on their state.
Is there a specific class handling task scheduling?
A class or function within the backworker manager class is responsible for checking if a task is ready to run, based on the scheduling criteria stored in the database.
If a task fails during execution, how does the backworker handle its rescheduling?
The backworker manager class will check if the task needs to be restarted, taking into account restart delay ms and crash restart delay ms values.
The add backworker function in listing 5 to 17 adds dependencies for the backworker. What are the key components being registered?
It registers backworker manager, iBackworker task factory, and the backworker hosted service. It also includes any assemblies containing task implementations.
Why is add singleton used for these components?
Add singleton ensures a single instance of each component is created and shared throughout the application. This is important for managing the backworker's resources effectively.
What is the role of action, backworker options, setup action?
It allows configuring the backworker options, providing values like connection strings or other parameters.
The code mentions add tasks implementations. What is the purpose of this method?
It dynamically adds task implementations from provided assemblies, ensuring flexibility in extending the backworker functionality.
The backworker hosted service appears very similar to the process-bot hosted service. Why is there duplication?
The similar structure suggests a shared architecture for background tasks. It likely reuses the core logic for handling periodic operations and task execution, which streamlines development and reduces code duplication.
What does Backworker Manager do in Listing 5-18 to fulfill scheduled tasks?
It retrieves tasks from the database, ensures only one pod processes each task at a time, and then runs the appropriate task implementation.
How is the run async method of Backworker Manager related to the scheduling mechanism, given the periodic execution by process-bot hosted service?
Run async is the heart of the backworker's execution cycle. Process-bot hosted service triggers run async at intervals defined by scheduling requirements.
What does backworker task represent in the context of the backworker?
It encapsulates the details of a scheduled task. This includes the task type, parameters, and scheduling information.
The code snippet shows get timelock start backworker task async. What does this method do exactly?
It retrieves a task from the active tasks table, marks it as being processed, and ensures only one pod can work on it concurrently.
What happens if get timelock start backworker task async returns null?
If null, it means no task is ready to run at this time, and the function returns without further action.
The try catch block surrounds the task execution. Why is this crucial?
It catches potential exceptions during task execution, preventing the backworker from crashing and logging the error.
Underscore backworker task log repository dot upsert start async and underscore backworker task log repository dot upsert stop async. Why are these calls necessary?
They record the start and end times of the task execution, crucial for scheduling and tracking its lifecycle.
How do restart delay MS and crash restart delay MS affect the backworker's behavior?
Restart delay MS is the delay before a task can run again after successful completion. Crash restart delay MS applies if a pod crashes, introducing a delay before another can attempt it.
The code mentions backworker task act. What is its role?
It defines the contract for task implementations. Different types of tasks implement this interface.
What role does underscore backworker task factory to get task play?
It creates the specific task object based on the task type.
Backworker task class in listing 5-19 has a needs to start method. Explain its purpose.
It checks if the task is ready to be run based on scheduling criteria, time since last start/stop, and lock times.
How does time to start calculate if a task is ready?
Time to start considers repeat period MS, restart delay MS, and crash restart delay MS to determine if the scheduled time has arrived.
The time to start method checks if a task is ready. How does it use the repeat period MS, restart delay MS, and crash restart delay MS values?
It calculates whether the current time has passed since the last successful run, the restart delay, or if a crash restart delay has passed, all according to the parameters set for each task.
Could you elaborate on how the schedule start time Boolean is calculated?
Schedule start time checks if the difference in milliseconds since the last start is greater than or equal to the repeat period MS and the difference in milliseconds since the last stop is greater than or equal to the restart delay MS.
What does the restart crash Boolean check for?
It verifies if a lock time exists and if the elapsed time since the lock time exceeds crash restart delay MS.
Why is lock time a nullable date time?
Lock time is nullable because a task might not have been locked previously. This allows handling cases where a task was never started, or a pod crashed before starting it.
If both schedule start time and restart crash are false, what does this indicate?
The task is not yet ready to run based on its scheduling parameters.
What is the significance of using datetime.min value as a default in this context?
Datetime.min value is used as a placeholder value to avoid null checks in time to start. This is effective for cases where there is no previous start or stop time.
Why is this logic important for the overall backworker functionality?
This logic controls the exact execution timing and restart mechanisms of scheduled background tasks to prevent overlapping executions.
So, restart delay MS is crucial for preventing immediate restarts. Can you explain why crash restart delay MS is equally important?
Crash restart delay MS ensures a pod failure doesn't lead to immediate retry by another pod. It introduces a delay before a new pod can take on a task locked by a failed one.
How does this delay help prevent conflicts?
The delay lets the active task's record expire, allowing another pod to lock and run the task without conflict.
In summary, restart delay MS and crash restart delay MS control the task's scheduling and restart, ensuring proper execution even with pod failures. Correct?
Exactly. They're vital for preventing race conditions and ensuring scheduled tasks run predictably.
The text mentions advantages of the chosen approach. What are some of these advantages?
The approach focuses on using commands instead of services, promoting code modularity and easier understanding of the system's operation.
How do these implementations of state machines and backworkers contribute to building applications?
They offer structured ways to manage processes and scheduled tasks, enhancing organization and allowing for more complex workflows to be implemented.
The text emphasizes that the provided information should be sufficient for building application services. What makes it so comprehensive?
The text covers crucial elements like choosing a technology stack, application architecture, including clean architecture and command handlers, ORM selection, and implementation details for state machines and backworkers. This offers a comprehensive guide.
Given the thorough explanation of these mechanisms, does the text suggest a particular way to implement application services, or is it more of a guide for various approaches?
The text provides a blueprint and basic implementation examples. It leaves room for various approaches within the framework it describes, allowing the reader to adapt the ideas to their specific needs.
So the text's strength lies in the clarity and practicality of the design concepts demonstrated, rather than imposing a specific implementation method on the reader?
Exactly. It empowers the reader with the knowledge to build appropriate services. The provided examples serve as starting points for more advanced implementations.
The text discusses using Dapper instead of Entity Framework. Why this choice?
Dapper's focus on mapping makes it faster than Entity Framework. It prioritizes speed, sacrificing some of Entity Framework's broader functionality.
So, the trade-off is speed for features?
Precisely. Dapper simplicity allows for direct database interaction, optimizing performance.
How does the DB connector class manage database connections?
It creates a new connection for each database operation. This ensures isolation and avoids potential conflicts.
Is that the optimal approach for all scenarios?
Not necessarily. For very high-volume applications, connection pooling might be more efficient. However, this example prioritizes simplicity and demonstrates the core functionality of Dapper.
The text provides a simple exchange order and exchange deal entity example. How does this align with the anemic model?
The entities are relatively simple, containing primarily data structures. Business logic is not deeply embedded within them, matching the anemic model's separation of data and behavior.
Why is exchange deal not considered an entity?
Deals depend on orders. They don't have their own independent existence, making them part of the exchange order entity.
The text explains migrations. How do migrations help in database development?
Migrations allow controlled changes to the database schema. They track additions, modifications, and removals of tables and columns, managing database evolution effectively.
The discussion of migrations focuses on Fluent Migrator. Why not other options?
The example is based on Fluent Migrator, which provides a straightforward approach for database schema management. Other tools exist, but this one is presented for its simplicity.
The text describes a finite state machine. What are its key components?
A finite state machine uses nodes, transitions, and events. Nodes represent states, events trigger transitions, and rules define the allowed transitions between states.
The example process map involves several node types. What distinguishes them?
Node types like act, waiting, terminal, trigger, and description define the actions performed. Waiting periods, completion criteria, event responses, and placeholders within the process.
The example uses a process map class. What role does it play?
The process map class manages the flow of entities through the process by defining nodes, transitions, and dependencies, providing a structured view of the process flow.
The example shows a simple implementation of a state machine. Are there potential downsides to this approach?
Simplicity is a strength, but more complex state machine features like concurrency and extensive branching might require a more elaborate implementation.
How does the hosted service mechanism improve the state machine's implementation?
Hosted services enable background task management. This decouples the state machine from the main application flow and allows it to run independently.
The text mentions using interfaces for ACT nodes. Why is this beneficial?
Using interfaces promotes code reusability and flexibility. It decouples the state machine from specific implementations, making it adaptable to different applications.
The example discusses a process ACT factory. What is its purpose?
The process ACT factory dynamically creates iProcess ACT objects. This enhances the state machine's flexibility and maintainability by allowing different actions to be used within the machine's flow.
The code shows a loop for periodic processing. How does this contribute to efficiency?
The loop enables periodic checks for new entities and events. This allows the processing of entities on a regular basis, ensuring tasks are handled efficiently.
The example runAsync method uses a cancellation token. How is this crucial?
Cancellation token allows external processes to stop the runAsync method. This is essential for graceful shutdown and preventing resource leaks.
The handle entities async function processes multiple entities. Why is this beneficial?
Processing multiple entities improves efficiency by minimizing the overhead associated with fetching entities individually, particularly in high-volume scenarios.
Listing 5 to 11 highlights the handling of events. How does the order of event processing affect the flow?
The function processes events in chronological order, ensuring the correct sequence of actions based on the time events occur.
How does the process map class handle transitions based on events?
The getNextNodeID method in process map determines the next node based on the current node and the received event type. This ensures that the machine moves to the correct state based on the events.
The text describes a backworker mechanism. What is its purpose?
The backworker handles background tasks scheduled to run periodically. This is useful for tasks like checking instrument strategy pairs or receiving data from exchanges.
How does the backworker's implementation relate to the state machine?
The backworker, like the state machine, runs in a separate process and needs to be decoupled. This allows background tasks to run independently of the main application flow.
The example backworker manager uses a repository. What is the role of the repository?
The repository manages access to the database table storing backworker tasks. It handles tasks like locking, retrieving, and unlocking.
The backworker task class includes fields like repeat period ms and restart delay ms. What do they control?
Repeat period ms determines how often the task should run, while restart delay ms defines a delay before retrying after failure.
How does the needs to start method in backworker task determine when a task should run?
It checks if the task is active and if the specified time period has elapsed since the last start or restart.
The example mentions the backworker task factory. What is its function?
The factory creates instances of backworker tasks based on their type, enabling flexibility and handling different types of tasks.
The runAsync method retrieves a task using getHandLockStart backworker task async. Why the locking mechanism?
Locking prevents multiple backworker instances from processing the same task concurrently, ensuring data consistency.
The runAsync method updates the task log table. Why is this important?
Updating the task log records tracks the task status, start, and completion times, crucial for debugging and monitoring.
The backworker task class includes magic string. What kind of data might this field contain?
This field can hold any task-specific data, such as parameters for the task execution. It could be a JSON string with complex configuration.
The text outlines similar patterns for the state machine and backworker. What are the key takeaways from these implementations?
The implementations highlight the importance of decoupling, using repositories for database interactions, and managing background tasks efficiently.
The text emphasizes the use of asynchronous methods. Why is this important?
Asynchronous methods allow the backworker and state machine to perform operations concurrently, improving responsiveness and performance.
In the backworker example, there's mention of multiple pods. How does this solve the issue of high volume?
Multiple pods distribute the workload, enabling the processing of numerous tasks simultaneously.